Hello everyone, my name is Sudeep Hazra and I'm presenting my idea of a fully managed cloud-based serverless and smart irrigation system called Jalsutra. Water in today's world has become one of the most prized commodities. We are consuming water at an alarming rate and might be left with very little for our future. If we take the entire water on the planet, only 2.5% of this reserve is fresh water. Out of this quantity, only about 1% is easily accessible to humans. Virtually no country on the planet is spared from the water scarcity crisis, with poorer regions of the world facing the most hardships. As per estimates from the World Bank, if we continue on the path we are today, there can be severe impacts on the economic well-being of any country by directly impacting the GDP to as much as 6% annually. The condition in my country, India, is getting visibly scarier, with entire metropolitan cities like Bangalore and Pune possessing no water to sustain themselves. These cities need to bring in water from rural areas, and thus the stress is transferred to rural communities as well. The condition in rural areas is profoundly felt, where usually women are subject to tremendous strain to procure water for their families. As per projection from several NGOs operating in India, an average rural Indian woman travels 1400 kilometers per year to get water for her family. There are several layers of socio-economic effects this water crisis has on the entire rural ecosystems, which range from women's health, safety, infant mortality, and a whole range of other problems. There are several layers of water consumption, but we targeted agriculture as it is estimated to consume 70% of all the fresh water on the planet, and as such, even the slightest savings in this sector will have profound effects on the entire planet. As per research available in the public domain, 30 to 70% of water used in agriculture can be saved by proper utilization. This is where Jalsutra comes in. In conjunction with optimal irrigation techniques, Jalsutra aims to save this excess consumption. On the brighter side, this savings would be in the vicinity of 5,180 trillion liters of water every year. That's a trillion with a T. This water is enough to harvest rice in the arid terrains of the Australian continent. Let's look further at a demo of the complete solution so that I can show you exactly what I'm talking about. So this is the detailed architecture of the system. We have on the very left our IoT sensors. These sensors that we've used here are the temperature, humidity, soil moisture, and rain sensors. They feed in data to a Raspberry Pi, which is a single board general purpose microcomputer. Raspberry Pi is running a version of Debian Linux called Raspbian, and we have a Python script which is running on the Raspberry Pi, which interfaces with the Azure cloud. Then this particular Python program is a two-way communication gateway between the Azure cloud and Raspberry Pi. So it sends out data to the Azure cloud and gets in data from Azure cloud. The input data from Azure cloud is then used to drive other devices which are attached to the Raspberry Pi. In this case, we would be showcasing a water pump and a drainage system. This is about the device, the physical device. Now coming to the cloud part. The Python program connects with Azure IoT Hub which acts as a bidirectional system for interfacing IoT devices. IoT Hub then sends in the received data, which in this case is a form of a serialized JSON string, into Azure Stream Analytics. Azure Stream Analytics then splits this data. One part of the streaming data goes to Azure Machine Learning. The machine learning model that we've used here uses the temperature and humidity information from our sensors and then predicts the chances of rainfall. This is an existing model that we've reused for our purpose. Once the calculations are done, then Azure Machine Learning sends the data back into Stream Analytics, and Stream Analytics uses this data to store into an Azure SQL database. On another stream of Azure Stream Analytics, the output is sent to be displayed on a Power BI dashboard. Now comes the third part. The third part is a very interesting one, wherein we send in data back to the device and then control other devices attached to our Raspberry Pi. So the third stream of Azure Stream Analytics goes to an Azure Event Hub. From the Event Hub, we trigger an Azure function. This Azure function interfaces with IoT Hub, and then IoT Hub interfaces with the Python program on the receiving end and sends signals back to the Raspberry Pi to trigger the devices attached to it. This is the basic architecture of the system. Now let's see a live demo so that we understand further how this system works in its entirety. This is our Azure dashboard, and these are the services that we have used. If you look from left to right, we have the Azure IoT Hub, we have the Stream Analytics job, we have the database, and then we have the function app. Now these are the parts, components or services that we have used directly from Azure. We also have Power BI. If we go to this tab, you see that these are the various cards that we have used, drafted something out very quickly. This is the title. We have the soil moisture sensor. This is the sensor input that's being displayed here. The probability of rainfall. This is the output from our machine learning module. This is the output from our rain sensor. It says 1 if it's not raining and 0 if it's raining. Then we have the temperature. It's a trend graph that shows over time, and this is the current temperature, the last successful read from the sensors. Then we have the atmospheric humidity percentage. This is the trend again from the continuous sensing or the streaming data based on time, and this is the latest record that we have. Hardware device that we have the Raspberry Pi here, the power source driving it, red light shows it's on, and we have a breadboard with all the components. So let me just describe the components for you. This is the soil moisture sensor. So whatever the moisture content of the soil is, it will sense and then it will feed in data to the Raspberry Pi. This is the rain sensor. So whenever it detects if there is any rainfall, and then sends the data through the breadboard into the Raspberry Pi. Now this little blue one here, this is the temperature and humidity sensor that we've used, and this also sends in digital signals directly into the Raspberry Pi. If you look at the Raspberry Pi, you see all the cables connected here. These are the GPIO ports. This is the Raspberry Pi version 3, pretty good stuff, and it connects, it nearly works like a normal personal computer. Now we don't have a water pump and we don't have a drainage system, so this is what we've done. We'll put in two LEDs. One is a green one here, if you can focus on the green one here, okay, and then we have a blue one here. So the green one represents our water pump and the blue one represents our drainage system. You'll see that the blue one would be demarcated by a blue wire and the green LED is demarcated by a green wire. So this is the program. This is called Calibre D2C. As you can imagine, D2C is basically something that sends in data from the device to the cloud. I've written another program which sends in data from the cloud into the device, and I've run it separately just for the sake of simplicity. We can see it here that it's running, and it says its status is idle. So basically it hasn't received anything back from the cloud. That's why it says it's idle. And if you look at the sensor data that is being sent, you'll see that it's sending Raspberry Pi Python, temperature 30, humidity 76, soil moisture 0, which means low, is raining 1, which means it's not raining. Let's look at a practical use case on how this entire system is designed and how it's supposed to work end to end. So let's look at this Jalsutra in live action. If you see here, this is the Power BI dashboard which is drawing in data from the Raspberry Pi connected through the Azure services, and you'll see that the data is getting updated. Right now the soil moisture sensor on the very left top says 0, it says insufficient soil moisture, and we've programmed our threshold soil moisture content in such a way that if it detects enough soil moisture, it would change the value to 1. And the rain chance, will do some calculations on the chances of rain. Right now our threshold is at 50%, so if we look at the probability, which is 58, this would suggest that there's a very good chance of rain. Let's look at the circuit to continue further. You see here that the soil moisture sensor is connected with the actual soil. This is dry soil, and I don't have my blue or green LEDs lit up, which basically says that I don't need to do anything with the water pump or with the drainage system. So this is again the threshold rain probability is set at 50%. So right now, as we saw, that we have 58% probability of rain. So it's a good chance of rain and it's not doing anything. Now let's change the soil moisture content. So I'll just pour some water here. Let it absorb. As I pour the water, you see that the soil moisture sensor temperature changed to 1, which indicates a sufficient amount of soil moisture. The next thing we've done is we've removed the soil moisture sensor from the soil. So right now it's detecting low moisture, and we've changed the threshold probability of rain to be 70%. So there's no rain, no chance of rain, and you see the green LED come up which says switch on the pump. The next situation that we'll look at is, what if the soil moisture is low, there's not a very good chance of rain, but suddenly it does start raining. So let's make it rain. Give it 20 seconds because that's the threshold I've set. You see the green LED come off, which means since it's raining, I don't need to have my pump watering the soil. Let's look at the next use case wherein you have sufficient moisture in the soil and it's raining, as the rain sensor detects it. You'll see that my blue LED has come up, which means I need to switch on the water drainage system. So this is basically a very quick and short demo as to what we have done. I know things can be extended, and we'd definitely like the opportunity to extend things and put it to a next level. Thank you for your time. Have a good day.